I know that you have been waiting for, a long, long, long time. So, ladies and gentlemen, here it is. And Cirky. She's missed you too. Mark your own, and all I care about is, did you get the right picture? So, A plus B, it would look like this. Vector A, I'm going to be fussy, put an arrow on the end of it. Vector B, I'm going to be fussy, put an arrow on the end of it, and the resultant is from the tail of the first to the tip of the second, and it should have an arrow on that end of it too. So for you to get the 1 mark, I'm looking for that slanty line there. Did you notice that your answer for question 2 looks exactly the same? Because when you add things, order doesn't matter. For number 2, I would do vector B first, and then vector A, tip to tail. But do you notice both of these resultants look identical? Yeah. Okay, C plus B. How do I add 2 vectors together? Draw them. So I drew vector C first. Then I drew, I'm going to need more room. I drew vector C first. Then I drew vector B, tip to tail. And I guess the resultant is going to be down and even more at a sharper angle and longer. How would you figure that out if you had numbers? Is that a right-angled triangle? No, you'd need the sine law and the cosine law, which you might remember from last year. Or if you did pre-calc 12 this year, you might have done it there too. Although, there's a cheap hack workaround where you can turn this into a SOHCAHTOA question. B plus C. Oh, I think C plus B and B plus C should end up with the same resultant in the same way that 5 plus 6 and 6 plus 5 ends up with the same answer. So that's going to look like this. I'll draw it on the left here. Here's vector B. Here's vector C. And then again, Paige, from the tail of the first to the tip of the second. Hey, yeah, if I could draw with a straight line, that's pretty terrible. These two do look the same. What about A plus C? Here's vector A, here's vector C, and I guess the resultant will be kind of a long slanty line there. I can't call that a hypotenuse because a hypotenuse is only in a right-angled triangle. It's the longest side of that triangle, but it's not a hypotenuse. Oh, A plus B plus C. Okay. A plus B plus C. And I end up with that. Or you could have done A plus B first, then you would have got that one there, Elias, and vector C looks really simple. It's basically, it looks like, I think, 2 of vector C's in a row. Something like that. Let me pause. Have I done anything that's dramatically weird, or is this hopefully fitting into the way it should for our rules for vector mathematics? Okay. What about number 7, 2A? That's 1A. That's 2A. A plus D. Done. 0. Now you could go like this, and I'll give you full credit for that too, but they cancel each other out, so if you left it blank, you're technically right. Okay. B plus D. Okay. B plus D. Oh, now I'm into familiar territory. Oh, change colors, Mr. Dewick. And again, I'm going to be fussy. You do need to put arrows on the ends of your vectors. Every year I have some kid that doesn't put arrows, and so they have this. Sorry, I can't even do it without an arrow. They have this, but then they can't tell which way the resultant is pointing. Down and left or up and right. Put the arrows on. 2B. Oh. There's 1B. There's 2B's. 11, 2 C's. Yeah? Ooh, 2a plus d. 1a, 2a plus d. You know what? I think you just end up with a single a. Elias? Thank you. It's me being me. Okay? I'm willing to bet most of you didn't get perfect, so your homework is do your corrections, and you can hand that in either before class is over today, there's still about 35 minutes left, or you can hand it in on the weekend. But that's your introduction to vectors. How do we add two vectors together? We draw them tip to tail, and then we get triggy with it. My goal is you get so good at trig, you get almost as good at trig as you got last year with formula manipulation. You are going to get very good at right angle trig and Pythagoras, because we're going to be doing it on every question. Okay? Where do we use this? I did one application question with you already, the airplane in a crosswind. Another neat example is a boat going across the river, which is the same physics as an airplane in a crosswind, but instead of a crosswind, it's a cross current. And then lots of other applications too.